So this unit, we just finished up talking about exponentials. Now this part of the unit talks about polynomials. A polynomial, let's start off by defining what a polynomial is. A polynomial is a mathematical expression that contains variables to different powers separated only by addition or subtraction. So these terms cannot be separated by multiplication or division. By definition, a polynomial is only separated by addition or subtraction. So to give us an understanding of what a polynomial is, let's give a few examples of what is not a polynomial. So a few examples of what's not a polynomial: negative exponents. So those powers must be positive. Variables in the denominator. So that's another way of thinking about negative exponents. You can't have that, no variables in the denominator. And then also multiplication or division, separating terms. So if it's got negative exponents, a variable in the denominator, or multiplication or division separating the terms, then it is not a polynomial. Let's take a look at the following expressions and determine whether or not they are polynomials. Looking at this first one, are there any negative exponents? No. And are they separated by addition and subtraction? Yes. So this is a polynomial. Looking at this next one here, I see already we've got a negative exponent, so no, this is not a polynomial. Looking at this next one, we've got terms separated by only addition, and there are only positive powers, so yes. This one here, we've got a variable in the denominator. We can't have that, so this is not a polynomial. Looking at this next one here, we have positive powers, no variables in the denominator. This 1/3 here, it's just a number, it's just 1/3. That's fine for polynomials, so yes, this is a polynomial. Now, if this was a variable in the denominator, this would not be a polynomial. This next one here, only positive powers, and there's no variables in the denominator, and it's only separated by addition and subtraction. So yes, this is a polynomial. The coefficients can be negative, but the powers cannot. Looking at this here, all of our variables are in the numerator. That's fine, and our powers are positive. We can always rewrite this as 1/5 times k to the third. This is a polynomial. This next one here, this is separated by division, so no, this is not a polynomial. Okay. Flipping to the next page here, we talk about naming polynomials. The first definition that I want to give is the degree of a polynomial. The degree is the highest exponent that the polynomial has. So a few examples. If the degree is 0, then we call that just a constant. A few examples, 5 and 2. Those are just constants. The exponent is 0. If the degree is 1, the exponent is 1, so 2 to the x, 2x. or negative 3x, we call that linear. And these vocabulary terms you must know. If the degree is 2, or the highest exponent is 2, examples include 5x squared or negative 2x squared. We call that a quadratic. Quadratic, a quadratic. If the highest exponent is 3, or the degree is 3, an example could be like 5x cubed. We call that a cubic. If the highest degree is 4, an example, 6x to the 4th, we call that a quartic. And last, if it's 5 or greater, then we just use that number. So an example like 8x to the 7th, just use that number. So we would call this a polynomial with degree 7. Okay. Let's also name polynomials by the number of terms that they have. So the number of terms in the polynomial, and we know what's a term by what's separated by addition or subtraction. If it has just one term, then we call that a monomial. Notice the prefix mono, or 1. If it has 2 terms, we call that a binomial. Again, the prefix bi, meaning 2. If it has 3 terms, we call that a trinomial. The prefix tri, meaning 3. And finally, if it has 4 or more terms, we just call that a polynomial. Poly meaning many. So an easy way to remember this is by their prefixes. Mono, bi, and tri tell you 1, 2, and 3 terms. Polynomial is just many terms, 4 or more. Let's classify the following using the number of terms and the degree for the polynomials. This here, the highest exponent, the degree, is right here, 2. The degree is 2. The number of terms that we have 1, 2, 3 terms separated by addition. So we would call this a quadratic trinomial. This here, our highest power. Remember, when it's not written, we can always say that the power is 1. So the degree is 1, and the number of terms, well, there's just one term. So we call this a linear monomial. Next up, our highest exponent, our degree, is 3. So our degree is 3. The number of terms, we have 1, 2, 3, 4. So this is a cubic polynomial. Over here we have our highest degree is 9, our highest exponent. And then our number of terms, we've got 1, 2. So this we would just call a 9th degree. And then the number of terms, 2, so this is a binomial. This next one, our highest exponent is 2, so our degree is 2. And the number of terms, 1, 2, 3. So this is a quadratic. And the number of terms makes it a trinomial. And last but not least, The highest degree here is 3. The number of terms, 1, 2. So this is a cubic binomial. As a reminder, the number of terms, 1 is a monomial, 2 is a binomial, 3 is a trinomial, and 4 is a polynomial. The degree is the highest exponent. We have a constant for 0 exponent. A 1 in the exponent is linear. 2 in the exponent is quadratic. 3 is cubic. 4 is quartic. And then 5 or greater, we just use that number. And that is objective 45.